Right. Today we'll start with the chef, right? So till now we covered like Docker, right? And we saw that Docker was basically maintaining servers in my containers, right? So you're having one server and multiple containers in it. But let's say you don't know anything about Docker. Let's say you did not. I mean, like your organization is yeah, sure. So imagine that your organization is not using Docker at all, right? They don't know like Docker exists. They are not aware of those concepts at all. Now, what you are having again, if you remove Docker from this environment, all again you are left with multiple servers, right? So you are having three servers for your load balancers. Let's say you are doing your project, you need Jenkins, right? You need Stormcat servers, you need Apache web servers, Nginx web servers. Nothing but again you are going to have machines again, not containers. Earlier we worked with containers because I know that whenever I want multiple environments, with the help of Docker, I can spin up containers and I can work on them. But let's say you are having multiple servers, right? So generally, at the end of the day, you are maintaining servers, even if you are using Docker. So what is Docker giving you? Basically, it's giving you containers inside that server. But that containers they need, let's say you are having multiple environments. Let's say you are having like around 15, 20 containers in dev environment. You are having another 15, 20 containers in your QA environment. Now these containers also taking up your what you say physical resources, right? I mean like from your host machine. Now, if they are very huge in number, again you are going to spin up multiple machines, right? So you are going to spin up multiple servers. Now, how you are going to manage them? That is very important. So earlier we used Nagios. What Nagios is doing actually? It's just like monitoring, right? What is the amount of RAM being used, hard disk being used, number of users which are there in the system. That is what it's trying to do. But generally, what happens with Chef is that it is going to do the configuration for you. Configuration in the sense, let's imagine in your particular environment, you are having 200 web servers, right? You are having 200 web servers. Now you need to change port. Let's say by default, what's the port number? 80, right? By default, your Apache web service is going to run on port number 80. Now you want to change all your web servers from 80 to 81. What are you going to do next? What is your next task you are going to do? Each and every particular server, and we know that that configuration is present under http.conf. Now we are going into 200 web servers, isn't it? Now we are going and modifying in 200 web servers, isn't it? Across your all the infrastructure. Now generally, let's say if you are having only 5 servers, it's an easy task, right? You'll go into file login system. I mean like you'll log into 5 servers. You'll go to http.conf. You'll change number port number 82, let's say something like 81. Fine. But let's say if you're having 1,000 servers, will it be an easy task? Because you're doing the same thing again and again, isn't it? We are always trying to observe that pattern. I mean like if you are doing some particular pattern again and again, we are trying to automate, isn't it? That's what we did all this out of time. So we saw every manual thing first, then we used tools like Jenkins, Nexus, Maven, these kind of tools, and we automated the development part. But when it comes to your infrastructure part, what's the automation you are going to use? That's what Chef is. So basically not Chef, configuration management tools. Generally we call them configuration management tools. Chef is one of that configuration management tool. So what it basically does means it is going to basically check for all your infrastructure and maintain some common rules. So if you define some rules, right, those particular servers which are there in your environment, either it's 10, 20, 100, 1000, 10,000 servers, n number of servers, they are always going to basically go with that same particular rules, right? So generally what you are managing actually complexity, right? Isn't it? Now when you talk about 2000 servers or 10,000 servers, it's going to be complex. If managing 5 servers, it's very easy, right? All you can do is like SSH into that specific machine, you can change the configurations without any problem. But let's say you are having above 1000 servers, 2000 servers, that's where complexity comes into the picture. So whenever you want to manage complexity, you always go for configuration management tools, right? Configuration management. Chef is one of the configuration management tools. So you got like different types of configuration management tools. Puppet, then you got something called like SolStack, then you have something called like Ansible. different, these are nothing but just the, what do you say, configuration management tools, but they work in different ways. I mean, like, let's say we were using different build tools, right? We saw make, and we use maven, right? We saw something called like gradle. These are all doing the same task, but the way of doing the things is different. Similarly, your configuration management also, just like the difference is like, if you take Ansible, it works on what do you say, Python. If you take Chef, right, it works on Ruby. If you take, what do you say, Puppet, it works on its own domain language. There is something like Puppet specific language for that. Like this, the working principle is same for all your configuration management tools. Just like syntax differences, the way how you work is different, that's it, right? So basically our Chef is also going to manage the complexity for us. You understood, right? What's the meaning of complexity? So let's say if your infrastructure is huge and maintaining becomes a problem, that's where we go with this kind of configuration management tools. Now, if you see, basically it is going with the items of manipulation. Now you see, whenever you are working on servers, what are you doing? You are installing some packages, right? You are creating some users. You are creating some configuration files. You are basically you are removing some packages, right? These were the tasks which we did from beginning of the time, right? So these were the regular tasks which you are doing. Basically, your system administrators do that, right? Now you see, basically whatever the tasks which we are doing, right? They are called resources in your Chef terminology. This is very, very important. So we had some terminology with your Docker, Vagrant, all these things, right? So we had something like instances, images, boxes, right? Here also we have a terminology called resources, which indicate nothing but the things which you are going to set up in your servers. It might be a networking part, it might be a file you want to change, it might be some directory you want to create or remove, it might be some symlinks you want to create, right? Maybe some mount points or registry keys. Let's say you want to implement some shell script or power script, right? Maybe you want to create users, packages, services, whatever we are doing with your particular thing in your machines, I mean, like in your servers, you want to manipulate them with the help of Chef. Why? Because now let's say you are telling that you are having 200 servers with you. Now in the 200 servers, I want 150 web servers. What are you going to do basically? You are going to install like yum-y install something like httpd, or let's say it's an Ubuntu based machines, right? You will say apt-get install Apache. This is what we are doing. But if you are doing that manually, it takes a lot of time. If not, you can use something like shell script, and that too by using the help of Vagrant you can spin up them. That is one task. But the problem is, if you write that script which we are writing in my, what do you say, shell script by using Vagrant, will it work for my Ubuntu machine? If I say yum install httpd, it's not going to work on your Ubuntu, right? There is no cross platform when you are using shell scripts or bash scripts. Now what are the cross level languages? You got something like Java, Python, Ruby, Perl. These are cross platform, right? They will run across different operating systems. Now basically all your configuration managements are built on this particular scenario. So when you are configuring it, don't configure for one environment. Configure either it's Ubuntu, either it's Linux, either it's some other SUSE Linux, right? That's how you're basically maintaining this particular, what you say, cross platform independent. Write it, run it anywhere you want. Now you are going to write scripts in such a way that they will execute, I mean, like you will be writing Ruby scripts, which is very, very simple actually. Now at the time of Vagrant we saw it, all we had was like do, end, right? Only you are going to do the same specific thing. So you're not learning from, I mean, like you're not learning Ruby from the scratch actually. So there is some equivalent Ruby code built for your particular packages, files, and everything already. All you need to understand is that part. If you are good with it, that. So actually we saw in Docker, right? So if you want to basically execute one particular command, what we are saying run. If you want to select the directory, what you're saying work dir. Similarly, like that, for each and every specific task in your Ruby, you have your equivalent, what you say, yum or apt-get. Depending upon your Ruby script, it gets executed. So you don't need to bother about that, right? So you basically understand, right? What are the resources? Resources are nothing but your something like files, packages, groups, which you are going to execute or install or start, right? So basically, with the help of Ruby, you are going to manage all these resources, right? And you see, basically this is very important. Now, let's imagine I am working on particular application. So I started with one server. Okay. Like earlier, right? So I was having one particular server. I installed Maven in it. I installed Git in it. I installed Jenkins in it. I installed Nexus, everything in one particular software because my application was very small at that point of time, which was just like hello world, right? So I don't need much processing power for just running something like hello world. So everything was confined in one particular server. But let's imagine you implemented lots of logic. I mean, like you basically, let's say, you went and enhanced your project step by step. Your application is growing up, right? Now, is it one server is going to be enough for me? No, right? So basically for running Hello World, okay, one server is good enough. But let's say you implemented something like registration, you installed something like login module got installed, right? You are basically, let's say you are implementing new features in your application, right? So at that time, what happens? Now, if you see, right, it says you might need something like database, right? So for Hello World, I don't need any database. But let's say if you want to do some login and registration, I need database, right? To store my usernames, passwords, information, and everything. So I got now two servers to maintain. One is my database server, one is for my applications to work, right? And in the similar fashion, you see, sometimes what happens, let's say you want the backup of your databases. Let's say if your database crashes, right, everything is lost, isn't it? Your data, everything is gone. What you're doing, you are creating one more a redundant database, which is nothing but replica of your database again. So that if something goes wrong here, you can pull up from here. Now from one, we became three servers. And if you go like that, maybe you need app servers as well, multiple app servers to basically distribute the load equally, right? I mean, like, you are you getting to, like, means like what happens is like once your application starts growing, right, your number of servers are also equivalently grow with that. Yeah. Let's say if your bandwidth is growing, your traffic is increasing. Generally, we went with that load balancing concept. We introduced that load balancer and we distributed the load equally. Similarly, what's happening here? Here also, your application is growing up and the number of servers required to support that application are also growing equivalent, right? And if you see that, you might need something like a load balancer, like I told you, to distribute the requests equally. Now, just like that, our applications with one server became almost like six servers right now, five servers, right? And if you go further ahead, you need more app balancers, load balancers for your application servers itself. Then if you go like that, you might need your cache for your DB, so that you don't want to send the request directly to database. You want to cache that in between other servers and you're giving the response from those caching servers itself, right? And if you go down, you see, so totally from one server we almost went back to like 6 plus 5, 11 servers, all because my application is growing up. Now if you take the same scenario with your organizations, right, this is going to happen in the same way. So let's say you are a startup, you implemented some particular new app, let's say new app, which became huge hit in the market. Now there are lots of customers coming in, right? Now you need to manage all these customers. Now if you don't have configuration management tools like this, you are with very risky position actually, to speak. Because if you can't spin up the servers, right, you cannot provide the services to your customers, which would be major loss for any organization which is at very what do you say it going at high level pace. Now to manage this, you need something like these tools where you can manage all these servers with the help of one particular configuration service, right? And you see, even not that, now you need to connect network between all these servers, right? So yesterday when we were dealing with AWS, just like connecting 2 3 servers only, it was very huge burden for us. But let's say if you're having 20 30 servers, how you're going to manage that all that network topology and everything? It's going to be more complex, right? Like this, if you keep on going with your organization demand, right, always your infrastructure becomes complex and complex and complex. So in real time, you might have 20,000, 30,000 servers as well to maintain all your infrastructure. I mean, like to basically to service your customers, right? And if you go like, you see, my complexity has gone too high right now. Right now, this is what is required to basically make my what do you say, to give service to my customers without any problem. These many servers are required. But if you see earlier, there was only one particular server which was very easy to manage. but currently you are having around 20 servers, right? You cannot go and log into each and every server, do task again and again, right? So basically to avoid all this, right, we are going with your configuration management tools. Now you see what it says. You understood the problem, right? What is the problem you are having? It is becoming tough to manage many number of servers if your what do you say, your infrastructure is growing very rapidly, right? To basically control all this, we go with something called like chef. Now chef, what it does, it manages complexity through some these particular things. So you have some components in chef which we need to understand. These are the components which help you basically manage your infrastructure, right? So you have something called like organizations. I'll talk about all this, right? You got something called like environments, right? You might have something like QA environment, production environment, right? And you have something called like roles, nodes, recipes. So these are nothing but internally your chef works on these components. We need to understand all these components definitely to start understanding your chef infrastructure, right? Now you see, when it comes to organizations part, right? So your organizations can be n number, right? I mean, like uh, let's see. Now you see, this is my infrastructure. This is how it looks. Your infrastructure might look like this. Some other person's infrastructure might look like this, right? It is always, I mean, like it is always possible that infrastructures are not common across all the organizations, right? It might be different for different organizations. So what chef does is, it will basically not say like how your organization looks. It does not care about that. It only cares about how to configure them. So it says, it does not say like, okay, your infrastructure should only look like this. If not, it should look like only like this. No. So it does not bother about it. It always says like, let it be anyway. I don't care about that. All I care about is like how to manage them. That's it. Right? So this concept can be applied across any organization you have and any infrastructure you have. That's what it tries to say, right? And if you see, organizations are completely independent tenants of chef enterprise. So basically enterprise chef is nothing but a server to manage all your infrastructure servers. I mean, like let's say currently you're having 500 servers, you want to manage them, right? These 500 servers will be connected to something called like enterprise chef, which is nothing but a chef server. So we had an AWS Course server, right, which was monitoring all your hosts. Similarly, you have something called like a enterprise chef server, which manages all your infrastructure nodes, right? And it says completely independent tenants. Why it says completely independent tenants? Now, if you take, right, organizations, they might have multiple business units, right, or multiple, let's say something like components inside itself. Now, if you take something like Tata, Tata has so many business units, right? They have automobiles, right? They have something like household goods, right? And if not, let's say if you take something like Amazon, right? They are also into multiple things, right? They are into cloud. They are providing e-commerce solutions, right? There are like multiple things which each organization provides. Now, is there any connection between e-commerce and cloud? No, right? They are completely independent tenants. Even if you take something like examples like Tata itself, your automobiles are completely from your consumer household items. There is no relation between them, right? So basically, each organization is independent itself. That's what Chef tries to say. So you should never combine other organizations' data with your organization. Organizations are completely isolated, different things itself, right? That is one important thing to notice when you are configuring organizations, right? And it says share nothing with other organizations, right? Because you are sharing your infrastructure itself, right? Basically, organizations are meant in such a way that you should not share your infrastructure with others. And it says your organizations may represent companies, business units, or departments itself. Now, if you take departments, is there any connection between your development department and let's say finance department? No, right? Development and HR. There is no common thing in between these business units, right? I mean, like let's say departments. So you're basically maintaining them independently. So organizations help you to segregate like this, independent of nature, right? So this concept, so whenever you want to configure your chef server, right? First, you need to configure an organization. Then environments. I told you, right? So in your particular organization, you might have different environments, something like development, staging, production, QA, right? Now, how you want to segregate them? Now, let's say you are having 1,000 servers. Now, you want to keep 200 servers for your development and 200 servers for your something like staging or QA, and another 600 servers for your production. Now, how you are going to manage them? That is with the help of environments. So you segregate them. So if you are having 1,000 servers, I'll put my 200 servers like my development, where only this particular infrastructure I can manage up easily without clubbing everything together, right? So if everything is clubbed together, you always have the problem, right? So let's say you want, like I told you, right? You might have something like web servers, application servers, database servers. Now, if you put everything together, it does not make sense, right? It is very hard to basically go and manage all this. So we are going to segregate according to some particular things like environments, roles, which would easily help you to go and organize your infrastructure, right? And you see, environments model the life stages of your application, isn't it? So basically, in your dev environment, your application might behave something like different. In QA, it might different. In production, it might be completely different, right? To manage this in this kind of what do you say problems, we go with the environments kind of thing, right? These are nothing but modules. So environment is one module, you have roles one module, right? You got different modules, right? And it says every organization starts with a single environment. So without environment, you cannot set up any of your nodes. I mean, like your servers. So once you create one particular organization, by default, it has a environment called default environment, right? If you want to work with your own, we need to go and customize our environments according to our use, something like dev, QA, or production, right? And it says environment to reflect your patterns and workflows, isn't it? Your workflow is completely different in dev when compared to QA. In dev environment, what we are doing, basically fetching the changes, building up, right? We are doing that package, we are transferring it into some particular application server. In QA environment, what you are doing, you are installing something like Selenium or let's say JMeter, and you are performing tests, which is completely different, right? When you compare with your QA and dev, so it says your reflects your patterns and workflow. It might be a different workflow when you take your things in dev environment or QA environment, and it would be completely different in production, right? Will you be doing any tests in production? No. All you have is working application over there, right? So basically, to segregate all these kind of things, we use environments. And it says you might have different environments to begin with. You might have development, testing, staging, production, something like UAT, different kinds of things, right? All this you can go and configure with the help of environments. And you see, environments define policy. This is very important. So what is policy actually? So let's say I'll talk about, and it's say environments may include data attributes necessary. So there are some attributes, I'll talk about this later. And it says the URL of your payment services, the location of your package repository. So basically now let's say whenever you want to go with something like database username and password, right? Now what happens, let's say how many databases you are going to have actually. I mean, like your application might not have multiple databases, right? Only one particular database. It might be a replication for different kinds of sets. Are you going to have multiple usernames and passwords for that? No, right? Your database is having only one username and that particular password to go and work with your database. Now, if you want the database to be used by all 200 app servers, right? You cannot go and say like in each and every particular server I'll add username and password, username and password, username and password. Isn't it? When you're developing your applications, you write in one particular file, let's say something like db.environments. You'll put database URL, a username, password over there, which would be used across your entire project. Similarly, we can use something called like attributes, which are global level. So you can define that globally and it can be used across all your infrastructure. That's what attributes generally do. We'll talk about all these things in depth. So every particular topic which we are talking, right, it almost takes up one class. So roles, something like environments, recipes, is will like very huge topics, right? And it says roles, like I told you. So we talked till now environments. Basically, you want to segregate according to your environments, but based on roles also you want to segregate. Let's say you want to give something like a web server role and keep all your 200 web servers in that particular role. Let's say you want to create a role called application server and you want to keep all your application servers in that role. So when you want to change something on your application servers, don't go and change in each and every server. Change in the role, it will reflect across all your app servers. Right? These kind of functionality can be achieved through something called like roles. So you can create some roles and define the particular installation or removal of package, or let's say any configuration in that role. It will apply across all your app servers. Right? So basically what we are doing with this is like we are basically like dividing and role. That's it. Now if you want to create one role where you want to check something like, let's say you want to add a user called something like admin, not only in app servers, web servers, but across your entire infrastructure. Let's say you're having 2000 servers. In 2000 servers you want to add. What you can simply do, you can create a role called global role and put all 2000 servers. Done. Create one more role, a role called something like load balancers, and keep all your load balancers in that particular level. It will go and affect only that thing. You understood, right? So basically like dividing and controlling that particular part. That's what basically roles are used. And if you see, roles represent types of servers. It can be something like your load balancers, application servers, database, monitoring servers, similar kind of things in one place. And you see, roles define policy. It says roles may include a list of chef configuration files that should be applied, and we call this list like a run list. So now let's say what happens is like whenever you want to install Apache web server, right? Let's say you're having 1000 servers like I mentioned. So you want to install web server in 200 servers, right? So whenever you want to install these 200 servers, you call something called like a run list. You write your configuration and keep that configuration in run list, and you'll add this run list in 200 servers. Right? So this is like more of theoretical, but once we enter into the practical, right, then it will make sense. Like, but you need to understand this theory also very, very important, because terminology is completely different when you come to configuration management tools, right? And it says roles may include data attributes, like I told you, right? So globally, I want to include something, then it goes with your attributes as well. And it says, you see, the port that you want to listen, right? Let's say I told you, right? Let's say in my particular role, I create something like web server and create role 81. Where 100 servers should only be listening to 81. That you can achieve with the help of these particular things. And it says a list of applications that should be deployed. Then it comes nodes. So till point of time, what we did with environments, we saw roles, right? Basically, these are nothing but like configurations, right? You want to configure something, but where you are doing all this configuration on servers, right? These servers are nothing called nodes. Nodes are nothing but the servers which you want to manage. So nodes are nothing but the servers which are there in your infrastructure currently, right? And it says nodes represents the servers in your infrastructure. And you see, nodes may represent either physical servers or virtual servers. So with the help of Chef, right, you can manage the servers which are there in your Google Cloud, which are there in your AWS, or let's say which you created with your something like Vagrant in your physical machine itself. So you can go and manage any server you want. All you need is the specific IP address of that machine and the sudo user, that's it. And the host name. If you have these three parameters, right, you can control any server you want. Right? And it says node may represent hardware that you own or represent compute instances in public or private cloud. I told you, right? So basically something like AWS or something like your Google Cloud, or let's say within your infrastructure itself. You can go and manage any server, or it may be on cloud, or it may be on your on-premise. And you see, each node will belong to an organization and environment. This is 100%. So whenever you create one server, right, I mean like one node, it should definitely be part of one organization and one environment. So whenever you want to start with Chef server, you definitely create one organization. Like I told you, by default, you have an environment called default environment. But node may have 0 or more roles depending upon your requirements. I mean, like, let's say that server is not a web server, not a particular DB server. It is something like our Bastion host itself. You're not going to have multiple Bastion hosts, right? You're having only one Bastion host. Now you don't want to include that as a part of this infrastructure. You can go and add no role for that, right? And it says nodes adhere to policy. So basically you need to understand policy importantly here. So policy is nothing but, let's say your node should follow these kind of rules. So what rules? Let's say Apache should be installed. That is the rule number 1. Apache should be started. Second rule. It should run on port number 8080. Right? Rule number 3. These 3 rules are like policies. Policy is nothing but when you say your server should follow these rules, it should definitely follow it. If someone tries to change them, they should automatically change back to the earlier configuration which you managed. Now let's say some person hacked your system and he changed everything in your server. Now you want to roll back everything. Now let's say you're having 20,000 servers. In that, something like 18,500 server is hacked. Now you cannot go and check like each and every server whether the configuration has been changed, isn't it? It's very tedious task. So instead of that, you'll tell chef to manage it. You'll not bother about it. You'll say, chef server, for this 18,500 server, this is the policy it should follow. If it does not follow, make sure it follows it. So you're completely automating it. Even if someone comes and changes, it will roll back automatically by itself. That's what we are going to do with the policies. So it's why it says an application called chef client will run on each and every node. So once you attach your node to this chef, right, in your chef infrastructure, there is a program called chef client which will run on your nodes, which will make sure that it follows the policies, right? Because now you are saying that you want to install web server. How it will understand it needs to install web server? Chef client will be there in your nodes. It will talk to the chef server. Chef server will say, okay, you need to install web server for you. Let's say there is database server. It will talk and it says, okay, there is a policy for you, defined database policy, which let's say you need to start installing database something like MySQL or PLS, right? And it says chef client will gather the current system configuration. I mean, like your nodes which are there, right? It will first, whenever you attach for the first time, it goes and it collects entire information of your node. What softwares are being installed, what ports are open. It will collect entire information, A to Z of your server, and it keeps with it. So there is a process called OHI, which we'll talk about it actually. That process will go and completely gather all the information from your nodes. And it says it downloads the desired system state configuration from the chef server. So all your configuration is not present in the nodes actually. It is present on chef server and it will come and talk to your nodes. And it says configure the nodes such that it adheres to the policy. Nothing but configure your particular nodes in such a way that they always follow the policy which is there in your chef server, right? And you see, it says chef is basically infrastructure as code. Now when we are talking about our last class, right, I mean, like that day we have seen infrastructure as service, right, platform as service, software as service. We got different things. Like this, we got one more component called infrastructure as code. Till point of time, how we are going and managing your infrastructure with the help of some particular commands, right? What chef says is convert your infrastructure into code. What would be the advantage if I convert it into code? We can reuse it, right? So whenever I was writing my Vagrant code, what I was doing, I'm just like upgrading that into my GitHub and using it same time every time, isn't it? Now if you write code, it is always reusable and easy to maintain. Why? Because we already learned GitHub tools, right? GitHub, which would help you easily go and segregate code everything, right? So basically it says programmatically provision and configure your components. Components are nothing but, let's say Apache is one component for you, MySQL is one component for you. Everything put it in the code so that you can reuse these components every time again. So let's say you have built one infrastructure where your infrastructure is around like 500 servers right now, which is in Hyderabad. Now let's say you did not use any of your configuration tools. You basically went like what we did till this point of time. Now if you want to set up the same unit in Mumbai, what you need to do again, you need to start from the scratch, isn't it? You need to start installing all these things by yourself on 500 servers, manage that 500 servers. But instead, if you use configuration management and make it like a code, put it into your GitHub. And whenever you want this infrastructure like 500 servers, right, don't configure it again. Clone it from your GitHub, do it by yourself. I mean, like, let Chef do it by itself. So opening up your new business units, or let's say scaling your infrastructure, becomes very easy in this manner. So you're not manually depending on some particular tools like Yum, apt-get, these kind of things. Chef will manage everything for you, but configure it perfectly once. So we saw the same thing with Nagios as well, right? If you configure it perfectly, it will take care of all your infrastructure. It keeps on watching it. Similarly, Chef does the same thing. All you need to do is like configuring is very important here, which is very tough with the Chef actually. So when you are going for these configuration management tools, right, it is somewhat typical to understand because you are going with code, we are going with infrastructure servers, different kinds of environments as well, right? And it says treat like any other code base. So basically something like you can update it in your GitHub, GitLab, anywhere you want, right? And it says reconstruct the business from code repository. So whenever you are opening your new business units, right? Let's say whenever you are opening new branches, right? If you need infrastructure, basically clone from them and start. That's it. Instead of creating it from the scratch again, right? And it says configuration code. So Chef ensures node complies with the policy. So I told you, right, what are policies? Nothing but rules to be followed. So when once you say like your nodes to be attached to Chef, Chef will make sure that each node will definitely follow these policies. In that way, you will maintain configuration same across entire organization, right? And it says policy is determined by your configurations includes in the nodes run list. I told you, right, run list is nothing but where you want like rules to be executed parallelly one by one. Those are called your run list. And it says reduces the complexity through abstraction, right? Because you are keeping everything in one particular abstracted place, you can configure that, start working from there. And it says store the configuration of your infrastructure in version control. Take up all your configuration, put it under GitHub, start working again, right? And it says declarative interface. So you can define your policies, same thing. Your policy states what stage, oh yeah, this is very important. So I told you like we have resources, right? So run lists are nothing but resources in order, right? Resources, package is a resource, file is a resource. If you want to install Apache, what you need? You need package, right? HTTPD package. If you want to install something like tree application, what you need? You need a package called tree. These are nothing but packages. So if you take, right, it says your policy states what state each resource should be in. So your resources we talked about, right, package file has something called like a state. Every resource has state. This state is nothing but it defines the policy. So I told you, right, policies are nothing but rules. Now if I tell package, what you are doing with package generally? Installing. If not, removing it. If not, updating it. Let's say you talk about file. What we are doing with the files? We are creating the files, putting the contents maybe, right? Maybe deleting the files. If you take something like systemctl or service, what is service we are doing actually? We did not install it. Yeah, starting the service. Installing is package. We might start the service. We might check the status of the service. We might start it. We might restart it. These are called states. So for a file, the state is create or not create. For a package, install or remove. For a service, it's start or stop. Making sense? Because this is what we are doing, right? Your entire class session till point of time. Let's say you're working with Apache. What you're doing? First, we are installing package. Then we started the package. We started the service. Then we created an index file. 3 resources. Package, service, file. Now you want to manage these 3 across 1000 servers. Tedious task, isn't it? If you are manually doing it. Instead of that, we will write the policies. Now let's say in your 1,000 servers, some particular system administrator unknowingly went and changed your port number from 80 to 8080. Right? Now you cannot go and check 1800 servers, right? I mean like your 1,000 servers and see like which server has been changed the port. If it changes from 80 to 8080, if someone changes it, it should automatically roll back to 80. Why? Your policy in such a way that, I mean like your policies is in such a way that it should always be on port 80. Chef makes sure that it follows that policy definitely. Right? So that's what it says. So every resource has a state. We need to define those states with your policies. It will automate. I mean like for the first time we'll run it default, I mean like manually. I'll show you how you can automate as well. So you can keep some time interval, let's say for every 1 hour, every 2 hour, yeah, cron jobs, every particular half an hour. It should automatically check and it should run it. You can use the help of cron jobs, you can run it. And it says chef client will pull the policy from the chef server and enforces that policy on the node. So what it says, policies are rules. So what it does, chef client, where will chef client run actually? On your nodes. Chef client will always run on your nodes and it will talk to your chef server. It sees what are the rules, I mean like policies which are there for this particular server, and it will enforce that policy on the node. Right? Actually, once you get to know the architecture of your chef, right, then it will make clear things for you. So I'm talking about lots of components, right? I was talking like roles, environments, right? I did not talk about cookbooks earlier. So I need to talk about policies, right? States, like different things, right? Chef is actually very huge too. So there are like lots of things you can do with the chef, right? Resources. I told you a resource represents a piece of the system and its desired state. What it says, a package that should be installed, a service that should be running, a file that should be generated, right? A cron job that should be configured, a user that will be managed. Now if you take user, what is its state? Either created or not created, right? So everything, every resource which you are working in your Linux is always state, if you remember, right? Any component which we work till point of time, isn't it? Your networking, network started or not, firewall stopped or started. Every particular resource has some state here. That is very, very important. With the help of this state only, we are going to manage your entire infrastructure. And resources in recipes, yes, now it is very important. So I told you what are resources, files, packages and all this, right? Now you have something called like recipes. These are also important. It says resources are the fundamental building blocks, right? Because those are the things which you are managing in servers, resources. And it says resources are gathered into recipes. It says recipes are gathered. What's the meaning of it? Collection of resources are called recipes, simply. Making sense? Collection of resources. So what is the resource which we talked about? We talked about file, we talked about user, we talked about package. And recipes ensure the system is in desired state, high level. So you put resources in recipes. Right? Now I'll show you one particular thing, then it makes sense. You see, recipes are configuration files that describe resource and their state. So you're having one resource, it has some state. You configure the state in recipes. Install, manage files, deploy applications, execute other recipes. Right? And if I go down, you see, it has some particular example recipe. How many resources I'm having here? 3 resources. Right? To manage web servers, isn't it? You need 3 kind of things. One is package. You need the service to be started. Then you need an HTML file to show your web application. Now what you're doing, you are keeping these 3 resources bundled together in one recipe. So if you want to write a web server, right, all you need is one recipe called web server and put 3 resources. A package resource, a file resource where you can put your configuration file or index.html, and a service. Combinedly together, they form one recipe. Making sense? So you are having resources. Clubbing resources into one particular thing would give you a recipe, right? And then comes cookbooks, one more higher level. Collection of recipes, nothing but. Say cookbook is collection of your recipes, right? So instead of, so in your cookbook you have multiple resources, multiple recipes, more higher level of abstraction, right? And it says cookbook contains recipes, files, resources, everything. So actually you are writing cookbooks which contain recipes. Recipes in turn contain resources. Making sense? So actually how you are writing, if you take any programming language, first you define package. In that package you are having multiple classes. In that multiple classes you are having multiple methods. Isn't it? If you take something like C or Java, you have multiple functions which are gathered in one particular class. You might have multiple classes like that, like multiple recipes, which might have multiple, what you say, packages again. So like that, it is basically trying to be like more of your programming kind of language. Like because we are writing the code, right? Basically, to manage it, it should look more or similar to your code like thing. So you're having more and more modular level. So you're having cookbooks, which is nothing but collection of recipes. Recipes are collection of resources. Resources have something called like a state. So at the end of the day, you are writing cookbooks which contain recipes which are also you are going to write, which contain resource which are also going to write by yourself. So first we put resources in recipes, recipes inside cookbooks. If you understood this, this is good enough. That is what we are going to do it actually. So as a chef person, right, you will be writing cookbooks to manage your infrastructure, right? And if I go down, you see, now like I told you, I have enterprise chef. What is it? It is like a server for me. You are having nodes. So currently I just took only one node. What I told, node has a particular application called chef client. What it does, it goes and asks your server, what policy should I follow? Isn't it? That's what I talked about, right? So if there is a policy defined in your server, your chef client will ask, what's the policy defined for this node? If you have another node, it might have a different policy for it, right? So what is your node doing? It is asking through chef client, what policy should I follow? Then what it says, enterprise chef server will have something called like a run list that is present in your chef server. Run list is nothing but, I told you, right, policies. So what are the policies you are having? You see, you have a recipe to go with NTP. You got have a recipe to create users. You got a recipe to create web server, right? So what it says, okay, you have a run list defined for you. So your chef client talks and your chef client, your chef server will say you have a run list which has 3 components. Now next what it does, you see, it takes this run list, applies it on the node. So earlier there is no run list on your node. Then it will apply this run list. Making sense? So all the configuration is present under your chef server. So what node is having? Node has a software called chef client which always talks to your chef server with regular intervals. I told you that we are going to configure that regular interval using cron tabs. Then it will ask, what is the policy I should follow? It says you have 3 policies. One is to create with NTP, then you need to create some users, then you need to create some web servers. It will go and apply it itself. I think now it makes some sense. So you are writing some configuration, you will upload it under your chef server. Your clients will always talk to your chef server asking for what policy should I follow, what policy should I follow. Then for each and every specific server or node, there is already a run list defined over in your server. That run list will be executed according to the configuration. Run list is nothing but collection of your resources, recipes and all this. Now you say run list specify policies. It says the run list is a collection of policies that node should follow. And it says chef client obtains the run list from your chef server. Then chef client ensures the node complies with the policy. I mean, like it should follow that policy which is there in your run lists. Making sense till this point, right? Now manage complexity, right? So that's what we are talking about. So determine the desired state of your infrastructure. So what it says, desired state of your infrastructure. So what is your infrastructure consisting of actually? Resources, right? Packages, files and all this. Resources have desired state. Then it says identify the resource required to meet the state. So you are the person who needs to identify what state it should be. If you say the state should be stopped for service, if it's stopped in your chef server, right? I mean, like it is configured in such a way that even if you start in your node, it will automatically stop after some time, because it is defined in such a way that in your server, if something is configured in your server, it will always follow that thing. Nevertheless, if you try to change or do anything, it does not matter, right? And it says gather the resources into recipes. Yes, we understood that, because if you take a recipe for creating web server, it have multiple resources put together, and it says apply a run list to each node in your environments. Your infrastructure adheres to the policy you mentioned in that particular chef server. Configuration drift. This is very important feature. What is the meaning of configuration drift? Like I told you, if you configured something and let's say by mistake or some miscommunication, one of the system administrator went and changed your port number configuration in one of the web servers. Now it should automatically apply it back, right? That is what is called your configuration drift. If you change some configuration, right, even if you change, it does not follow it. According to that specific interval, it will talk to your chef client, reapplies it back to your node. So if someone hacks into your system, changes some configuration, right, even though if he tries to do that, it will automatically apply it back. That is one advantage which you get with that, right? So this is all you need to know about theory part. So this is very important actually. When it comes to your interviews, right, they'll definitely ask what are resources, what are recipes, what a resource has. It has a defined state already, right? So you have recipes. So what is resource actually? Yeah, it can be something like a service, a file, or a package. So what we are doing with that resources, what we are defining on those resources, we are defining some state, right? First, a state. Whenever you are configuring resources, you always configure their state first, right? If it does not have a state, it does not make sense, right? If you are using a resource, I told you by default it has some state. Without state, you cannot do anything, because what your policies are trying to do, they are trying to put this state under control, right? So that's the reason why we are more focused on resources. At the end of the day, you are writing cookbooks, recipes, everything, but inside your cookbooks or recipes, all you are defining is resources and their states, right? So there are like multiple resources. I mean, like whatever we did, right, we'll try to implement the same thing here. Installing some web servers, right, changing their configuration, applying it back by using the chef server itself, right? And you have something called like recipes, where you gather resources together, and you have cookbooks where you gather recipes together. So on the high level, first you are creating cookbooks. In that cookbooks, you are defining recipes. In the recipes, you are defining your resources and their states. That is very important. If you have knowledge of this thing, right, you are good to start with chef. So on the top level, first we got cookbooks. Under that, recipes contain resources. Resources have their state. If you have if you clear with these four things, right, you can start with this particular thing, right? So is it clear? I mean, like, this is very important to understand this theory part as well. So when you are going to define, right, you are going to define with this terminology itself. Writing cookbooks, writing recipes, right, defining resources and their steps. Right? This is only the theory you have. That's it. You don't have anything else apart from this. Once this is done, tomorrow we'll see how you can go and configure. Now, when you're configuring your chef infrastructure, right? What you did with your Nagios, two servers are not going to be good enough. Minimum of the minimum, we need three. If you want to check multiple things, you might need like 5, 10, depending upon your usage. Right? So in the open version of your chef server, you are going to have around 25 nodes you can configure for freely. Beyond that, we cannot configure in the open source. Right? So tomorrow we'll see this installation part of it. So even the installation is very huge in Chef. So we need to go and configure your Chef server first. Then you have a component called workstation we'll discuss tomorrow. Then you are going to configure your nodes. Right? Even configuration itself will take 1.5 class. Just for installing the setup. Once the setup is done, then you are going to write your servers, recipes, cookbooks, and everything in that particular configuration. Right? So tomorrow we'll start with the practical part of it. So we'll use the Google Cloud itself, because we actually you can do the same thing with Vagrant, but most of your systems are somewhat less memory and these kind of things, right? So we'll directly go and try with the Google Cloud itself. Right? We'll set up all those machines on your Google Cloud. We'll try to go and work with that. Right? Yeah, today I'll stop it here. I know today is most of it theory, but once that particular theory is done,